Okay, good morning. Good evening. Let me make this. Okay, so we were talking about the SQL architecture and so how SQL Server executes a select query and how SQL Server run update query, right? So what are all components we require in a so database architecture or SQL Server architecture. So in this we talked about network libraries, right? So we have three network libraries. The main that we use TCP/IP for the communication, wide area network communication. So we discussed about the various components in the relational engine. So how the data, how the query will be parsed, how the optimizer generates a plan and all like we talked about, and where the data will be stored. So we discussed all this, right? So where data will be stored, so where the plans will be stored in the memory, right? So we have a plan cache and we have a data cache. Now let's understand. So you have a query. That query has to execute, right? So what are all resources which are required to execute? So the first resource which is required is the CPU, right? So whatever you execute, that has to execute on the CPU, right? So the query has to execute on the CPU. Without CPU, so the queries cannot execute, right? So that is where we have something called user mode scheduler, right? So we will talk about the user mode scheduler in this session, right? So user mode scheduler, or even you can call it as SQL operating system, right? So this also you can call SQL OS, right? So we'll talk like, so why user mode scheduling uh, we have, right? Okay. So this is what we will be going to talk, right? SQL operating system or user mode scheduler, right? So why we call it as a user mode scheduler is, let's say, so Windows operating system, if you go to the task manager and go to the performance, you have something called CPU, right? Let's say I have in my machine, I have four CPUs, right? So I have four CPUs. SQL Server, how SQL Server understand that Windows machine has four CPUs and then I'll have to go ahead and execute, because even SQL, we will have something called scheduler, right? So scheduler is basically known as CPU, right? Suppose if you go here, select star from sys dot, if it is sys dot OS scheduler, right? So this scheduler is basically one-to-one mapping with the SQL operating system, where, right? So there are few other hidden schedulers. Scheduler is basically where the request is scheduling. So we will talk about that, what is scheduler and all. For now, understand that. So whatever CPUs that I have in the Windows server, right? So every query executes on the CPU, right? So whatever queries that you are executing on the SQL, that will go ahead and execute on the CPU, right? But how SQL Server understand that, so there are four CPUs and all. So we have something called schedulers, right? So scheduler is basically what the threads will be scheduled, right? It is kind of, so job that you have. So that will be scheduled. So it's a C threads also will be scheduled on that particular CPU. So here we have four CPUs and it will be mapped with schedulers, right? So don't worry, we will talk about this scheduler. Just wanted to show you the query we have in the SQL Server, right? So in this section, so we will talk about the basics of the scheduling. So why we have scheduling, what is the scheduling and all. So we will talk about the basics. So what is preemptive? and non-preemptive scheduling. So we will talk about that. So UMS basics, right? So what is this UMS? Why we require UMS? UMS is basically user mode scheduler, right? So there are two things. Scheduling is different. User mode scheduling is different. What is that user mode, right? So we will talk about that. Some troubleshooting things, right? For example, let's say uh, you have a thread executing on the CPU, which is not coming out of CPU, right? So those are the things we will talk about. First, let's understand before even move and talk about the scheduling, let's understand the process and the threads. So in simple terminology, right? So in just a layman terminology, process is nothing but an application that you are executing on the server, that you are installed on the server. Let's say you have a SQL Server installed on this computer, right? Go to the task manager, details, right? So whatever we have it here, whatever services that are running, everything we call it as one process, right? SQL Server is a process, ssms.exe is a process. So whatever we have installed or we have on the server is called as a process, right? So in this terminology, a process is I'll show you here. If you see here, a process does not execute or run any of the threads. So this as a unit of threads, unit of execution unit. I mean, the process is a kind of container. You can consider that, right? So let's say this is a container, is called a process, um, and which executes a threads, right? So there will be multiple threads that we have, and it executes your workload. This is the process, right? So process is basically, so collection of threads, right? So which executes your workload, right? So process is simple words. What I would say, whatever application that is running on the system, that is called one process, right? Whereas processor, right? So whereas processor, this four CPUs that we have, this is one processor, P1. This is another processor, P2. This is another processor, P3. This is another processor, P4, right? So there are four processors that we have on this computer. Each processor will allow all the application, doesn't matter like how many applications that you have on the system. So every application queries will go and execute on individual processors, right? How that queries will be executed, that we will talk in a bit. But each processor you can consider a kind of container for your threads, container for your executions, right? So this will be executed, right? So this is considered as a container for your executing executions, right? I will talk about the threads. That is the reason I'm not talking the word thread, but this you can consider it as a processor. This is one processor. This is one processor. This is one processor. Each processor will allow you to execute your workload, right? With respect to whatever process that I have on this computer, right? So this is not specific to process, right? So if I have multiple applications on this computer, so each application you call it as a process, right? So even SQL Server, you call it as a process, right? In simple terminology, let's say if you go to performance monitor, and I don't know whether you used or not, just I'll show you this. And don't worry what is this tool and all. This is the inbuilt monitor tool where we can track some of the performance counters, right? So we have something called, so that I'll show you what is the how this looks like, the processor and process, right? So that you will understand. So you have something called here, s- these two. So you have process and processor, right? So if I expand the processor, and you will see here 0, 1, 2, 3. These are called your CPUs, right? I have 4 CPUs, and these 4 CPUs are bound to processor, right? Processor is basically a container which gives the infrastructure, right? So infrastructure as in CPUs are in infrastructure to execute your workload, right? So that is what we call it as a processor. Whereas process, if you click on the process, click on any of these, right? You see all the applications here, right? Including your SQL Server, everything will be here, right? For example, Avast antivirus, right? So CMD, CMD process, right? I mean CMD shell, right? So whereas everything, right? So even if you go Explorer, that's what I see here, right? Details. I'm just keeping it here, minimizing, right? So explorer.exe. So you will have that zoom also. Like if I click here and type Z, zoom, right? So and SQL Server. So click here, SQL. I mean, searching a keyword, yes, right? So you have a SQL Server, right? So you have a SQL agent. So every application installed on this computer is called as a process, whereas processor is a container for your application to execute your queries, right? So it provide a infrastructure for your application to execute queries, right? That is the difference between process and the processor, right? But who is executing? I'm keep talking about the executing your queries. Who is executing, right? The process itself will execute? No, process will not execute. Again, process is again a kind of container I was talking, right? For your queries, right? Who is executing the queries is your worker, is your so worker, or we call it as a thread, right? So you will have a threads where it will be executing your queries, right? So in this process, you will have a multiple task, right? Let's say, for example, okay, what is this? Right? So you're executing some query. Select star from um, person dot person, right? This is just a simple query. This query is considered as a task for SQL Server, right? A task will be created. I mean, task, this is considered as a task. And likewise, in SQL Server, you will have multiple tasks, right? So whatever queries that you are executing at the SQL, all considered as multiple tasks, right? So each query or each operation is considered as a task. This task process will not execute. What it will do, this task will be bound to a thread, one-to-one mapping. This task will be bound to a thread, will be assigned to a thread is a worker. Let's say, for example, I was talking about the construction, house construction, right? House construction, there are different task will be there, right? So what we call um, anything like, so pillar or ceiling, flooring, whatever it is, those considered as a task, right? If if a person, I mean a worker is assigned to that particular task, so that worker responsibility is to take forward the task, right? So that is what it is, right? And the same thing, right? Even for the construction, multiple workers can be assigned to a task, right? So let's say it is so a wall construction. So a wall has to be built, right? So in a simple and taking, so the wall cannot be built by one single worker, right? It can be given to multiple. The same logic applies here as well, right? If the task is complex, if the task is complex, multiple workers can be assigned to that particular task to process your request, right? We will talk about that. That is what we call it as a parallelism, but we will talk that later, not in this, not now, right? For now, understand. So in this process, you will have multiple tasks to execute your workload, right? So each task will be bound to one thread. Thread is basically a smallest unit of your execution, right? Right here, a process as such contains several individual tasks that may not be depending on each other. Definitely, right? Let's say, for example, here, um, what I would say, let's say you have, okay, select. Okay, fine. So what I'm doing, so select star into person, right? So it's a, let's say kind of temporary table, right? So select star into a person. Okay. So this query is depending on this because first query executes and insert the data into the temporary table. Then only I can execute this query, right? This is what we call it as a dependent. The second query is depending on first query, right? So what I mean, whether the query may or may not be depending on each other, this makes us to do design. I mean, no. So what I mean, these can be dependent or cannot be dependent, right? Multiple threads can be dependent, not dependent, right? Multiple tasks can be dependent or not dependent. With respect to whether it is these are dependent or not, your threads will go and pick up the task and start executing that, right? Threads has multiple execution context in a process. This is what it is, right? So the thread is a smallest so unit of your task work execution, right? Smallest unit which takes your workload and executes on the CPU, executes the queries, right? So this is what it is, the process and the threads. Process is basically a uh, you can consider that it has multiple tasks which gives the task to the threads to execute the workload, right? Process will not execute any of the queries or any of the workload on its own, right? Process is just an application which has the which is kind of container for your task, container for your workload, whereas the threads will be assigned to individual task. The task will be executed by the worker or the thread, right? Both are same. Worker, we call it as a Windows terminology, and the thread, we call it as SQL terminology, right? Right. This is same thing, right? So what we talked, thread is a unit of execution within the process. Multiple thread can exist with a process. That's what I told, right? So thread process is giving a infrastructure for you to execute multiple threads. Each is given small amount of processor time, right? So each query that you execute, let's say you executed this query, you executed this query. Each query that you execute, it requires a processor time. So this time. Let's see. Sorry, I stop sharing. So this is the processor time it will be giving. This is what it is, right? So each is given small amount of processor time. Waits while other threads executes. Call scheduling. So we will talk about this, right? So we will talk about this point. What is this? And what does it mean by waiting, right? Now, SQL Server uses OS threads to perform its work. So what does it mean? We will talk that 1 second. Okay. Let's say this is your SQL layer. This is your Windows layer, or this is your operating system. Okay. So this is your SQL Server.exe process. Again, I'm talking process, right? So this is your SQL Server.exe process, which has multiple tasks. I mean, which doesn't have multiple tasks. Users are connected to the SQL Server and multiple tasks will be created, right? This can be a select, update, delete, whatever task that is, right? So each task will be, this is not a different different thing, but I'm just for you to understand, I'm just adding this like this, right? Let's say this is your thread, one thread. This is another thread. Thread one will be assigned to task one, right? Likewise, thread, okay, thread two, thread two will be assigned to task two. Okay, so these are the threads. This is at the SQL layer. There are two layers, right? So SQL Server and the operating system, right? This is operating system where we install the SQL Server. Now, these threads has to be executed because it doesn't have anything to execute the query. So it has to connect to the operating system and execute on the CPU, right? So threads, we call it as a threads here. And Windows doesn't know what is the thread terminology and all. So Windows, what it considered as worker, right? So whatever thread which is executing on the SQL Server, it will be mapped to the Windows worker and the worker will execute at the Windows layer. That is what it is, right? So this is called as a worker, right? So in the Windows level, it is called as a worker. So the thread which is taking up the task at the SQL level, it will go and execute at the Windows level. So Windows level, we call it as a worker, right? It's called worker threads. Dedicated threads exist such as the performing checkpoint, deadlock monitor, and ghost record. So what does it mean? Okay, 1 second. Okay, let me explain this. SQL OS, right? So this is SQL Server and SQL OS. So you have 4 CPUs. Let's say multiple CPUs, whatever that we have. 3 CPUs that I have, right? So Windows level, I have 3 CPUs, right? So you can go to Task Manager. That is what you see here, performance, and you have multiple CPUs on this computer. Now, so in the SQL, so you have, I was talking about the multiple tasks, right? So you have a multiple task here created, and each task will be assigned to a worker thread, right? Each task will be assigned to a worker or a thread. Okay, so before even that, let's take in SQL Server, so we have something called scheduler, right? So this is what I was talking, sys.dmos scheduler. Scheduler is basically basically a one-to-one map with your CPU, right? One-to-one map with your CPU. Suppose if I have 4 CPUs, I will have 4 schedulers. Scheduler is basically a SQL terminology where it schedules your threads. Hmm. Okay, so this is each CPU, each scheduler will be mapped to one CPU so that your queries will go and execute on the CPU, right? So that the queries will go and execute on the CPU. Hmm. Let me, okay. So you might have a question, right? Since we have this, 1 second. Okay. Since we have a operating system, since we have a, so Windows CPU, so why do we even require a scheduler, right? So why do we even require a scheduler, right? What is the purpose of scheduler when there is a Windows operating system? Let's say, so let's go a step back. I mean, not here. But let's take if so in the earlier versions of SQL Server, what happened? There is a Windows operating system, right? So when there was no UMS at all, right? When there was no UMS at all. But just a moment, let me see. Okay. Right. So when there was no UMS, right? Earlier versions, right? SQL 2000, so earlier version 7.0. So earlier version, there was no UMS, user mode scheduler. It was not there. So we all rely on the Windows scheduler, right? Whatever threads that we have on the system, so everything will be go ahead and execute by the SQL operating system. Now, what will happen? Let's say SQL Server has 4 CPUs. Sorry, Windows has 4 CPUs. And SQL Server, let's say there is a limit, right? So the number of limit or number of threads it can spawn is there is a limit, right? Let's say, for example, there are 512 threads are executing on the CPU or 512 parallel workers are created, right? So you have multiple tasks on the SQL. So each task will be assigned to a worker and you have around like 512 workers are created or 512 threads are created. So earlier versions of SQL Server, what will happen? Every thread on this computer will go ahead and execute on the CPU, right? So we'll go ahead and execute on the CPU. So now what will happen? All 512 threads will be spawn as in will be queue in the uh, Windows operating system, right? Everything will be in the queue and each thread will be executing on the CPU. So in this case, what is the drawback is like if every thread execute on the CPU, right? So let's say for example 512 threads, right? Thread is nothing but your execution unit of your task, right? Everything will be executed. Then what will happen? So all threads are all CPUs are busy because you are spawning all the threads at the CPU level, right? So this will be impacting the performance of your workload. Now, what we have achieved with the UMS is we are not sending all the threads to the Windows operating system, right? We are not sending, we are controlling, we are scheduling the threads, right? How we are scheduling the threads are, let's say, for example, I have a 512 threads. This 512 threads will be divided by number of CPUs. For example, I have 3 CPUs, right? 512 divided by 3, right? Whatever threads that we have. Right? For example, 170 threads. Just an example. Per CPU, 170 threads will be allocated. Right? So this is 170, this is 170, this is 170. Right? So this is in a round robin fashion. Let's say first thread will be assigned here, another thread will be assigned here, third thread will be assigned here. Then again, it will come back to the first thread, first CPU or scheduler, this one. So likewise, it will be mapped or it will be assigned to the scheduler in the SQL Server layer, right? So this scheduler, what it does out of this 170 threads or out of 170 tasks or threads, it will not allow all threads to execute on the CPU. Earlier, without UMS, what happened? All 170 will go ahead and wait on the CPU itself. That caused the CPU spike. Like there are multiple performance issues, right? With the UMS, what SQL layer we are controlling, we will schedule one by one thread instead of all 70. What the SQL layer will do, okay, go ahead and execute only one thread at a time on the CPU. It will allow only one thread. It will schedule only one thread on the CPU. Once this thread completes its execution, or if thread wanted to come out of the CPU, it will come out of the Windows operating system and go back to the scheduler, the same scheduler it is, right? Then next in the queue will go ahead and execute. So that is the reason we call UMS as a user mode scheduler. User mode is basically the SQL layer. We have a scheduler which manages our thread execution, right? So that we are controlling the CPU usage. We are controlling here, right? The scheduler basically a user mode. There are two modes. One is user mode. Second one is kernel mode, right? Whatever process we are installed on the system, operating system, right? Each process we call it as a user mode process, right? Each process, even it is a command prompt, even if it is a SQL server, even it is a PowerShell, everything, each process is called as a user mode process because user install the process, managing the process, right? Kernel mode is basically your operating system, right? Windows operating system. This is what it is, right? User mode scheduler, right? So this scheduler is responsibility is to schedule your threads, right? Suppose if I go back, hmm. So sys.os schedulers only. If you see here, well, I'll take this. Okay. If I see here, just I'm taking this, right? So I have CPU. So if you see here, on an average are equal, right? So all almost equal, right? Whatever it is. So you have 12 tasks assigned for one CPU. If I go back here, CPU ID, right? In the CPU ID, we assign 12 tasks, right? So as I told you earlier, task is basically assigned to a thread to execute, right? And CPU 1 is assigned 12 threads or 12 tasks. 2 with 10, maybe like, the completion of execution or whatever it is. 3 has 4, right? Maybe CPU availability and all, it's spawn on CPU 3, whatever, right? Doesn't matter. So on an average, around 12 threads are assigned to each individual CPUs, right? That is what I was talking. So this is how the threads will be assigned, and SQL process will take care of the scheduling because SQL know our process. Windows doesn't know. Windows doesn't make any sense that Windows manages our execution, right? Our process, we know the priority, like when to execute, when to not. So everything we know. So that will be go ahead and execute. So we will talk about the priority in a bit, but for now, understand.
Question. Mm,
Yeah. Any questions?
yes. So when do you know when to increase the CPU? When
When
do you
do you know
know? Yeah,
when
when to
to?
increase the CPU? From what you showed now, now if we have 12 tasks running on a particular CPU, and how do you know when to say, okay, server team increase the CPU because of the number of tasks is high?
Hmm. So we will talk that CPU usage and the CPU troubleshooting. But for your answer, to answer your question, let's say, for example, you have only 4 CPUs, and let's say your workload is very high, like the number of tasks or the transactions are high, and each query is not taking much time. Let's say, for example, within a milliseconds, the queries are completed, right? Even if the queries are completed within a millisecond, so since you have a huge workload, let's say for example, you have so hundreds of queries are executing, right? And you have a 4 CPU, it can be a 4 CPU, it can be a 12 CPU, whatever it is, doesn't matter. So the request is, let's say you have a huge workload and each query is not taking much time. Each query is taking only a few milliseconds. There is no chance of fine tune the query because the query is not taking longer. It is just a few milliseconds. There is no any so issues with the query execution. But the problem here is with the workload, right? You have a huge workload increased and each query is taking only just a few milliseconds or even a nanosecond. So just executing as fast as it is uh, executing. It is connected to the SQL, right? If that is the case, right? So you have a huge workload and each query is taking only a few milliseconds and your CPU doesn't have sufficient so CPU cycles. Your queries doesn't have enough CPU cycles to go ahead and execute the queries. If that is the case, you will have to maybe consider increasing the number of CPUs. Let's say you have 4 CPUs and again, okay, just to answer to, let's say you have around some queries, let's say around 500 for 300. Let's take this example, 300 queries or 300 transactions that you are executing. Let's say transaction, I'm talking individual transaction. Let's say here 100 transactions or 100 threads, and here 100 threads, here 100 threads, right? Each thread coming here and executing and going back, each thread coming here and executing and going back. So it's a very fast, but the CPU is not idle, right? CPU is continuously busy because you have huge workload to take your request, right? Here hundreds of queries. 100 is just an example that I was talking. It can be any number, right? If you have a huge queries which are in line and you have a huge workload, so the queries will be kind of so keep executing on the CPU and waiting for the CPU, right? If that is the case, then you'll have to consider increasing the number of CPUs, right? We have something called wait type like SYS scheduler yield, right? So most of the queries are waiting for SOS scheduler. This is the common wait type. Don't misunderstand. If you notice this wait type that you'll have to go ahead and increase. It also depends on your workload and the query execution time also. But we will talk that when we were talking about the wait types, right? Because whatever queries that we are executing, I said only one thread will go ahead and execute. Remaining everything will be waiting on the CPU. But this one thread also not taking much time, just very fraction of seconds, milliseconds, it is executing and going back. And then the CPU workload is high and the CPU is very busy and you don't have enough CPU to execute your queries. The same thing happened here. The same thing happened here. Everything is um, occupied and you don't have enough CPU cycle to execute, right? So in that case, maybe you can consider increasing the CPUs. I mean, before increasing, you'll have to check certain things, right? One query is slow. If there is any query slow, or if there are any high compilations happening or recompilations happening. So those are all many things that you'll have to check. But to answer your question for now, if you see a situation like this, maybe it is a good candidate of increasing the CPU. Is it clear? Did I answer your question?
Oh, sure, sure, absolutely.
Yeah. Any questions here? Maybe we will talk about the scheduler, like how the scheduling and all when we were talking about the preemptive and all. For now, understand because even I'm talking about the threads and the here like scheduler, you might not be able to understand. That is the reason I just wanted to show you here right away to understand
So, excuse me, the recompile you're talking about, are they both ad hoc?
everything.
Okay.
Whatever it is, like if you If your optimizer compiles, that requires additional CPU cycles. And if you have a huge number of compiles and batch, the number of executions and number of compiles are huge, it doesn't matter. Either it is a ad hoc store procedure, whatever. Any questions on this? If any questions or if you want me to explain anything, you feel free to ask, then I'll try to explain. Okay. Now, along with this, along with these threads I was talking, right? So far I was talking about the tasks that users are created, right? There are some threads for your dedicated workload. Let's say, for example, checkpoint. We were talking about the last class, right? So checkpoint, this also executed by a thread, right? So there is a thread for the checkpoint also. Every frequency, like whatever frequency that we have. So in that every frequency, a thread will be, so a dedicated thread will be assigned to a checkpoint. Likewise, lazy writer, right? There are some background threads. We will talk about what is this deadlock monitor later. For now, this is another background thread. It checks if there is any schedulers are deadlocked. That is another thing, right? So there are non-yielding, right? So non-yielding is basically a thread is spawned and executed on the CPU. What is that? Executed on the CPU, but this thread is not yielding. Yielding, what is yielding? Yielding is basically a come out of CPU. We will talk that in a bit. But for now, understand if the thread is not yielded, that also has to be monitored by the non-yielding scheduler, non-yielding thread, right? So this we will talk. That is what it is, right? Deadlock monitor and ghost record, whatever it is, we will have a dedicated worker. Okay. What pool of threads, right? So this is simple. This is same as like what we talked, right? So you can consider that pool. Pool is nothing but a collection of threads, right? So you have a collection of threads is considered as a pool, and each thread will go ahead and execute on the CPU from the pool, right? So this is what it is. Pool is basically a collection of threads that we have. Most are in the pool of threads that SQL Server uses to process your user request, whatever it is. Thread scheduling. So this is what I was talking, right? SQL Server has its own thread scheduling, right? So SQL Server has its own thread scheduling called non-preemptive scheduling, right? So non-preemptive scheduling is more efficient than Windows scheduling, right? Performed by the SQL operating system layer of the storage engine. Okay, I'll remove this, everything. Again, going back to the same. Suppose if you have this, I was talking, these are the schedulers. And I was talking, these are the Windows operating system, right? Let's say I have 100 threads here, 100 threads here, and 100 threads here, right? So as I told you, SQL Server will be assigned each one thread at a time to the operating system layer, right? It will schedule one thread at a time. So remaining thread will be in the queue, first in, first out kind of thing, right? Whenever the thread is come out of the CPU, the another thread out of 99 will go and execute on the CPU, right? So earlier version, I mean earlier as in like when there is no SQL operating system, what will happen? All 100 threads will go ahead and wait here on the Windows operating system, right? All 100 threads will go ahead and execute, go ahead and wait on the operating system, and it doesn't know which thread has to execute when, right? So which thread has to execute when. So it has a mechanism. The Windows operating system has a mechanism called preemptive. Um, hmm. So as a mechanism called preemptive. Preemptive is nothing but whatever threads which is executing on the scheduler on the operating system, doesn't matter whether the task is completed, the thread will be kicked out of the CPU, right? So the thread will be kicked out of the CPU so that the another thread in the CPU will go ahead and execute. So you know what I mean? Like let's say 100 threads. Like if there was no Windows, if there was no UMS, user mode scheduler, let's say 100 threads are spawned here. This spawn is nothing but it is just allocated to here, thus Windows operating system, see Windows schedule CPU. Let's say this thread, one thread is executing its task, one thread is executing, then it doesn't matter, like because this doesn't know what is that thread work is, right? Either it requires to run or it has to kick out of CPU, whatever it is, it doesn't know. If that is the case, it will be moved out of the CPU. Out of the CPU as in like executing. Let's say this is currently running. It will go out of the CPU and waiting the waiter queue, some queue, waiting thing. Next, again, the query executes and it will go. So likewise, it will keep switching. It will keep going back and forth, right? So what is the preemptive time slants is 4 millisecond, right? In this 4 millisecond, whatever thread which is currently executing on the CPU will go out of CPU. This is what preemptive. So we have something called non-preemptive, right? So the one of the another reason for SQL operating system is it is a non-preemptive scheduling. Whatever threads which is executing, which is scheduled on the CPU, that thread will not be preemptive. Preemptive as in like it will not come out of the CPU until and unless there are certain reasons. One, the thread execution is completed, or thread requires some waits, right? Let's say, for example, it needs some lock, it needs some pages. If that is the case, that cannot keep waiting on the CPU. It can come out of the CPU and it will go back to the particular scheduler, right? So that is the reason, even if you notice the blocking, right? If the query is blocked, or if you notice the blocking, the query will not be waiting for longer duration. I mean, sorry, the blocking query or the blocked query is not taking any of the CPU cycles. CPU cycles are zero, or CPU cycles are very low until what it was blocked, right? So what I mean, if the thread is waiting for some resources, it will come out of the CPU, go back to the SQL scheduler. So the whenever it is need some resources, the query will be go out of CPU, right? Mm, let's say some yield points. What does it mean by yield point? This is what we call it as yielding. Yielding, yes, Sridhar.
Chandu,
Mm,
preemptive and non-preemptive is not clear. Can you please repeat it again? What my understanding is
mhm.
preemptive, irrespective of whether the thread is completing the task or not, it will after 4 milliseconds or particular time interval, it will again go in and wait for some period till it gets the opportunity to complete the task. Is it?
That is correct. So that is correct. Just one step back. For example, let's say this is your CPU. Let's say Windows operating system, right? So this is your CPU, and I have let's say multiple threads or workers are executing. Worker or thread, I would say. Thread 1, thread 2, not executing again. So it will be in a queue. Even Windows operating system, these threads will be in the queue. Only one thread will execute, right? These in the queue. This is the currently running thread, right? As I said, it doesn't matter either whatever UMS or SQL Server, only one thread at a time will execute. Now let's say preemptive is nothing but um, preemptive is nothing but it will come out of the CPU. Simple thing. It will kicked out of the CPU. Let's say the thread 1 is completed only 30% of work. Doesn't matter whether that is completed or not. So there is, let's say, if it is a Windows operating system, let's say if it is not UMS, let's say there is a high priority thread, right? High priority. There are multiple reasons it will be preempted. One will be if 4 millisecond, I will talk what is that word quantum, but 4 millisecond is completed, then the thread, whatever percentage it is complete, sorry, whatever it is completed, it will be kicked out of CPU, right? And then it will allow other thread to go ahead and execute. That is how the preemptive. The second thing, there is a high priority thread. For example, let's say this is running priority level 7, for example, right? So there is another high priority thread. The Windows layer, it requires, it has a different priorities, right? So let's say there is a high priority thread at the Windows layer, some Windows kernel thread or something that is executing. If it is a high priority thread comes in, then the thread which is currently executing on the CPU will be kicked out of the CPU and allow other high priority thread to execute on the CPU. This is what it is preemptive. Preemptive is nothing but the thread will be come out of the CPU and will allow other thread to execute with respect to whether the task is executed, completed or not.
So even at the Windows level also there are priorities for threads which will work.
Hmm,
I mean the workers have the priority.
hmm,
In case if there is a higher priority than worker 1, for example, worker 7, we have a
hmm,
higher priority at that particular instant.
hmm.
So in that case only it will push worker 1, or just
Yeah,
it
there are
is a
two
4
things.
milliseconds, it will
Both
put it into
cases.
queue.
Both cases. In both the scenarios, let's say for example, if it is 4 milliseconds completed and 4 milliseconds completed, okay, so this thread 4 milliseconds is completed, let's move out of the CPU. Next,
In either case, if it is high
either case.
priority,
Hmm,
in
hmm.
between, if there is high priority, it will push before more 4
4
milliseconds.
millisecond. Yes, exactly. Even let's say 1 millisecond it is. So if there is a high priority comes in, so it will be kicked out of CPU.
It will be in queue again because
It
it
will
is
be in
not
the queue.
completed.
Correct, correct.
Okay. So, okay. Preemptive is clear. Okay. Sorry. Go ahead.
Hmm. So now what will happen to the everyone is clear, right? So this is just understanding. Let's say now this is 30% is completed, the thread. So if 30% is completed, now let's say we have, let's say two more threads execute, right? So this will be going and executing and whatever the 4 milliseconds completed, then it will come back in the queue and the next thread will be executing. So now the thread 1 chance will come again to execute. Does it take another, so from the beginning? No. So whatever it stopped, it will start executing. So, right, how that will stop executing? There is some registers at the kernel level, right? There are some registers. So that registers will have the context of the particular thread, right? So we'll have the particular thread context, right? So what is the thread context? What is the thread ID? What is the percentage it is completed, and from which it has to start with, from where it has to start with. So this is what we call it as a context switching. So context switching is basically the context will be switched back and forth, right? So what does it mean? Whenever the thread wants to execute its work again, the context switch will be loaded, the context will be loaded and start working on 30%, start from 30%. Whenever another 4 millisecond is completed, if the task is only 60% is completed, again it will go back and write the context into this registers, right? This is what context switch happens. If there is a high context switches, then there will be a high CPU usage. For that reason, we have something called UMS, user mode scheduler. Now, why I called it as a user mode scheduler? Unless these points are met, the thread will not come out of the CPU. The thread will not come out of the CPU. Here, 4 milliseconds still applies at the Windows layer. But what we are controlling here? We are controlling the thread scheduling. Earlier, we spawn all 100 threads. So all 100 threads in the queue. So every 4 millisecond, each and every thread will come out of CPU, and it will another thread will be loaded, another thread will be out of CPU, another thread will be loaded, and we are increasing the context switches. But what we are controlling with the UMS is the scheduling of the threads. One thread will be executed. The thread will not come out of kernel, out of the Windows operating system until and unless these are met. Thread execution is completed. Let's say the thread execution is completed, then it will go out of the CPU. Or if it is waiting for some resources, the thread cannot wait on the CPU. So it will come out of the CPU and go back to the Windows, go back to the UMS or the SQL scheduler, and will wait at the SQL layer. Or if there is a yield point, right? Yielding is basically come out of CPU, right? Preemptive is nothing but preemptive is meeting the condition, right? Yielding is come out of the CPU, right? So yield points as in SQL developer as in not our individual application developer who has developed SQL Server .exe, right? I don't know how many of you know, like SQL Server .exe is written in C++. The most of the code on SQL Server.exe is written in C++. Whatever C++ code written in between, right? So whatever the code that we have in between, there will be some yield points, right? Yield point as in whenever your query execution, whenever your execution touches that yield point or meets that yield point, then the query should come out of CPU. It should not run longer. I mean, even if it is, if there is a yield point, the query should not keep executing. Then that is what we call it as either it can be a SQL bug or it can be a some, so majority of the case, it can be a SQL product bug, not your individual application. If even if it is not coming out of CPU for a extended duration, or even if there is a yield point, then it will be come out of CPU. We don't have a control on this yield point, and we don't have visibility when this yield point will be met. But you will see a non-yielding thing. kind of non-yielding scheduler, right? So when the thread is not yielding from the CPU, that is where you will hit a non-yielding scheduler situation, and a thread will be, sorry, dump will be generated, right? This is what it is non-preemptive. The non-preemptive is basically with respect to, so uh, there is no priority level basically, right? So they doesn't have any priority level. If you see here, I'll show you. If you see sp underscore read error log and go back to the text mode and execute. See here, SQL Server is starting at normal priority. So whatever queries that you execute at the SQL level, it doesn't have any different priorities. All SQL Server queries threads will have the same priority is 7, right? SQL layer. Windows level, there might be some different priorities. So we have basically priorities from 0 to 32 priorities. Not we, like a Windows level and all. So there are 0 to 32 levels of priorities. SQL Server, we all have the same priority called priority 2. No, sorry, priority 7.
So
Hmm,
in case of non-preventive scheduler,
hmm,
non-preventive whatever it may be, so it's basically like we have some control on threads,
hmm,
so that that particular thread after completing T1, in Windows level it will be the same concepts or the
hmm,
same way it works in
hmm.
the it is only in preventive mode, okay.
Correct. Hmm,
But now we are only controlling or managing so that thread 1 will not come out in like in preventive case. So it
hmm.
will, after completing T1 only, T2 will goes
Correct.
to preventive. Like the other thread will be T2. Unless T1 is not completed, the other threads are not put in queue in preventive mode, right?
Correct. Correct. So what we are controlling here again. So let's say earlier, if there was no Windows operating system, all 100 threads will spawn and it will be in the queue in the Windows level. So every 4 milliseconds, all 100 will be preempted. I mean, all 100 will be not yielding and coming out, coming into the CPU and all, like based on the 4 milliseconds of preemptive scheduling that we have. Now, what we are controlling, one thread only we are sending to the operating system. So operating system, you have one thread and that is currently executing. And this 4 milliseconds, the logic is still applies. When like let's say for example, you have another threads, another thread at the Windows level, right? SQL, we are not sending any of the threads if one thread is already sent, right? So what if there is a PowerShell thread, CMD thread? There is a some so some other threads that are in the queue or the Windows layer, right? So if that is the case, that 4 milliseconds it will come again. It will be context switch happen. It will be another thread. It can be a PowerShell thread. It can be a CMD thread. It can be any other application threads will go ahead and execute on the CPU. That can take CPU cycles. That is the reason we all suggest to have the dedicated machine for the SQL Server, so that it will not, some other application would not impact the SQL workload or SQL process, right? So if there is any other threads, let's say for example, SQL we are not sending. Let's say there are 10 other threads. It can be some other Power BI, it can be SharePoint, it can be some other application that they're executing on the same server. So then all 10 threads, including SQL, will be on the on the operating system. So one thread executes 4 milliseconds come out of CPU, and the thread 4 milliseconds come out of CPU. Likewise, it will be. Suppose if any of the threads will have the highest priority, then 7. So that thread will go and execute. So that is the reason we all suggest to have a dedicated machine for SQL Server so that other applications like SharePoint, like Power BI, or like any other Java based application, .NET based application will not overlap or will not impact your your SQL services. Right? Maybe while talking other slides, maybe here and there I will touch all these. But yeah, here is it clear? Or any questions or any confusions? Okay, let's move forward. Hope this is clear. Maybe, so your day to day, here just one thing, so you might um, see something, right? So let's say, for example, the query is running slow, right? So if the query is running slow, this is not a core topics, right? So performance tuning or performance understanding of the performance is not something that so your installation core subject core SQL like always on or high availability, not like that. So you will not have any errors to troubleshoot, or you will not have any what I would say, like the failures or errors or nothing, so to troubleshoot the issues, right? Here, if you, as long as you understand the concept or the base or the internals, that would definitely help you to troubleshoot or understand the performance easier, right? For that reason, even if you feel, you might feel that like why I need all these things, but understand these are all things which are important for you to understand the basics. Otherwise, it would be easy to troubleshoot any of the performance issues, in my opinion. Okay, so this is what I talked. Each process has a scheduler. Scheduler exists for user threads and for internal operations. Internal operations, I was talking that checkpoint, lazy writer, whatever. Right? So use the sys.dmos schedulers, DMV, to view the schedulers, right? That's what I was showing, that sys.dmos schedulers to see the number of schedulers, right? So if you notice, select start from sys.dmos schedulers. There are multiple hidden schedulers also, right? There are multiple hidden schedulers also, right? There are some other internal tasks which SQL Server itself will be taking care. So that is the reason it no need to execute on the CPU. So that is the reason we have some hidden schedulers with SQL Server internally, which takes care of that, and it is not visible online, right? Whatever visible online, we will be having. So we have one more scheduler called dedicated administrator connection. Mhm. Right? So we have 5 threads. Sorry, this one, right? So we have a visible online is what you are, so CPU and all. So we have another one for the DAC, dedicated administrative connection. Let's say for all CPUs are busy and you're not even able to open a connection to the SQL Server. So you can still open a connection using the DAC, dedicated administrator connection, to see what is happening. So we will take one of the sessions and see how to connect a DAC if there is a complete kind of,
Can you do it now, please? Is it possible?
mm, it is possible. Connect. So it's just simple admin. So you'll have to open a connection. So this will be let me here. With respect to whatever SSMS version, so you should be able to connect using admin thing. So
So the admin recognizing that DAC, recognize the DAC.
deck, yeah, correct.
Okay.
Or you can use admin recognize the deck. So here sometimes we would not be able to connect. Okay. So SQL browser and check the error login time attack expect network related not found. Okay. I'll see. Like I think there is some my browser in browser. Why browser is required? I don't think required. Mm, Even A is a parameter where you can use and connect. So you can give it a try. Like I think it works, man. I don't know why this is not working here.
You go through the CMD because I know that you're unable to before you use DAC, you should be unable to get into the SQL Server. So do you have to go through CMD to run the query to connect using that admin?
Ah, so SQL Server query, it will work. I mean, this one I'll have to check why this is not letting me to, but this will work. SQL CMD will work. Even SSMS should work. Like suppose if you, I don't know if there is any reason that I open multiple connections, but yeah, so it should work using the admin colon.
So in what sense do you use SSMS for it?
Sorry.
When do you have to use SSMS? When do you have to use a DAC for SSMS?
That's what like this is SSMS DAC as in like yeah, this is just wanted to connect and execute the queries, right? The same thing like even if you SSMS or command prompt that you can connect. Doesn't matter like SSMS, even you can connect and execute. Let's say for example there is a huge blocking and you want to understand that what is happening. So even through SSMS also you can connect. So this PowerShell or command prompt SQL CMD, you might not execute the whole query or so it would be difficult, right? So in even SSMS also you can connect the DAC, open a DAC connection and execute the queries. Only thing why I don't know, like now it is not connecting. Maybe I'll have to see why that is not connecting. Uh, Basically, like, so if you open SSMS and just type this admin colon, and it should work. If this doesn't work, at least from the SQL CMD, it should work. Browser by browser. See here. Hmm. Select star from sys dot with what's the query.
So this connection should be a DAC connection, right?
It should be a DAC connection, correct?
Because we have logged in as admin.
Correct. But I need to check why even browser required. Like browser, I don't think it is mandate for admin for DAC connection.
In
But yeah,
that
so
case, I think we need to give the port number because
that's
it
what
is a named instance, right?
correct. The port number is required,
Either
but
enable
mm,
browser or port number.
mhm. If that is the case, let's see. Mm. Should not take this. Okay, fine.
So you can, instead of command prompt, can we try from SSMS by mentioning the port?
No, so again, like, I can mention, but here the problem is not with the port, I believe. So the
Okay.
reason, like, it is a local mission, right? So local mission doesn't even require a port to be specified. So this should work. So if port is required only if you are connecting through a remote mission. That's okay. Like you can give a try. Maybe if I find like I'll see. I notice like sometimes like it doesn't even work for SSMS. I don't know if any issues with the SSMS or not. Especially like my local mission. Like I have tried multiple times with my organization, like so from SSMS and connecting admin connection DAC and all that works, right? I don't know if anything here. 1 second.
If you check the name you have, your name is TECHNET, but on the CMD you have I after the H. Do you want to check that?
What is that?
Now, when you check your name, your domain name, you have TH, yeah, you have I after the N, right? Or there's no I?
No. This is correct. Like if this is not, if there is no port number, that is working.
Oh, probably my I is messing me up.
Hmm. This is not working because I might have opened a connection. That is the reason.
Okay, your name looks correct.
Browser, yeah, name is correct. Okay, that's fine.
Okay.
Like this is nothing to do with like so we troubleshoot. 1 second. 1 Fine. That we will see. Like maybe one of these sessions that we work on, like maybe um CPU we will talk about, not CPU, like even CPU memory we will talk about one of the sessions that I have demo so that we can check. But yeah, so I'll see like why we are not able to connect. Even I noticed this multiple times, right? This is not the first time that I noticed. Like whenever I'm trying to connect using SSMS, that at least that I notice some issues, right? From command prompt, it should work. I'll have to check like why it is depending any depending on the browser. Definitely looks like it is depending, but I will see and check that. I will see and check. 1 second. Some nine SQL Server start. So nothing, like I just changed from dynamic to static and let's see.
I think it should work now because
Let's see. Hmm. Okay, fine. Let's see. Hmm. I think it is connected, right? Interestingly, failed to connect server admin. Okay. Check. Let me see. I don't have a query. Hmm. Fine. So with this, I see like, so 79, this is some case, right? So EP that session, like running a deck, who's running a deck, what is the endpoints, EP, yes, sessions. Okay. Yeah, whatever. So at least I see here EP underscore name, EPs endpoints. Why undelegate administration select staff from okay. Okay, so at least I see here, right? So dedicated administration connection that is open. But what I noticed here with the browser, but I will have to really wanted to check like why browser, because I'll have to enable some port or something or a firewall. I don't know. I'll have to see that. Yeah. So anyway, like so that might be one of the reasons that I was able to connect using um, organization network, right? Because that will have a proper restriction and enabling, everything as is needed, right? So this is my local mission. Maybe I'll have to work on like why if there is any network or firewall or any port that I'll have to disable, something that I'll have to check. But yeah, you can see here, if I enable the browser service, that is where I see, the admin connection that I'm able to open. So this is how that you will be able to connect to the DAC dedicated administration connection. Okay. Yeah, I think we spent some time on that dedicated. Any questions, Santosh? Okay, so this is what we talked about, preemptive versus non-preemptive scheduling. Windows uses a priority driven. I told you, right? So it is a priority driven, whereas like whenever there is a high priority thread comes in, so the other thread will be kicked out of CPU within quantum, right? So Windows uses a priority driven preemptive scheduling algorithm, right? Windows thread executes within their quantum, right? So I told you 4 milliseconds. 4 millisecond is a slice quantum that the query executes on the Windows operating system will be kicked out of CPU whenever whenever it meets the quantum, right? Uh, Once the quantum expires, that is 4 milliseconds is expired, thread are scheduled off. That is kicked off from the CPU and most wait in the NT to schedule them again. NT is nothing but a Windows kernel, right? So that will be in the kernel only again, right? It will not go back to the SQL. It will be stayed in the kernel only, even if it is once the thread is completed, it's 4 millisecond quantum, right? Potential for threads to be preempted before quantum expires by high priority threads. This also I talked, right? If there is a high priority thread comes in, even if the thread execution is only 1 millisecond, the thread will be kicked out of CPU, right? UMS is a cooperative user mode scheduling subsystem. I will talk why it is cooperative, right? So I'll tell you here itself. Okay, I'll clear this. This is your Windows. This is your SQL. This is your Windows, right? So you have one CPU, one CPU. Here, another CPU. Uh, so there are two schedulers here at the SQL layer. And here we have SQL OS Here Windows OS, Windows operating system. Now, what happens? So I told you, right? Here, let's say there are 10 threads. Okay, 10 threads. Here, let's say then 10, I would say, okay, no. So 10 threads, and here it executes one thread, right? So it executes one thread. Now, this thread has to come out of CPU, right? This thread has to come uh, out of Windows CPU. So it will go back to the SQL OS. So I told you, right? What are the scenarios it will go? One is if it requires some resources, let's say locking, or it needs some pages, page IO, or page, right? It can be anything. If it is waiting for some resources, it will go back to the SQL. Waits or completion, the thread execution completion, or if it is yield point, whatever it is, it should go back to the SQL operating system. Now what will happen? How the other 9 threads or the next thread in the queue understand that, okay, this thread is coming and this thread has to go. This thread doesn't know anything. What is this thread actually does is, whatever thread which is coming out of CPU, it will give a signal to the thread in the queue. So it will send a notification or signal to the thread which is in the queue saying that I am coming out of the CPU. Next thread should go and execute on the CPU, right? Next thread which is ready for execution, go ahead and execute on the CPU, right? So this is what we call it as a cooperative, right? So cooperating is nothing but this will be communication. There will be a communication between the threads. Whatever thread which is coming out of CPU, it will send a notification or signal to the thread which is there in the um, which is there in the queue saying that, okay, so you go ahead and execute the next available thread, right? So that is what we call it as a cooperative user mode scheduling. Simply put UMS is a thread pool, right? Definitely it's the thread pool of threads. LOS equal to smart about when it waits, right? So LOS equal to be smart, right? So SQL know when to execute, when to run my queries, right? LOS equal specific management of CPU time, right? So specific management. Now we are not following that 4 millisecond, so scheduling mechanism, because that is a quantum at the Windows level. SQL Server, if it is scheduling its own scheduler, own threads, SQL Server should know when to schedule and how much time the query should execute, like when to yield the thread. So SQL Server know, right? Again, this is logical. It is not a physical. UMS is a logical. SQL operating system or SQL scheduler is completely logical. So we do not change anti-scheduling behavior. We just manage it, right? So what it says, NT is nothing but your Windows kernel, right? What we call it as a NT. Uh, so what it says, UMS is just a layer on top of the Windows operating system. We are not changing anything to the Windows operating system. We are just managing our scheduling so that the threads will go ahead and execute on the Windows operating system. This is high level of preemptive, non-preemptive, what we already discussed in detail, right? So this is basic architecture of the CPU, right? So this is what it is, right? So you have a UMS, and I was talking about the 3 scenarios when the query will go out of CPU. One is waiting. Second one is um, task is completed. Third, like suppose if the yield point met and it should come out of CPU. Now, I'll just let's say this is your SQL. Here it is your CPU. Here it is CPU. Here it is another CPU. Now let's say I talked about scenarios, right? Let's say, for example, it is waiting for some resources, wait resource. the thread waiting resource and thread ready to execute, right? So there is a difference. What is the difference? Ready to execute is nothing but it is not waiting for anything. It is just waiting for the query which is running on the CPU to give, or the thread which is currently executing on the CPU to give a signal to the thread which is on the CPU to go ahead and execute, right? That is ready. It is ready, like it is waiting for signal from the CPU, from the thread which is running on the CPU. So that is what we call it as a ready to execute. What it is waiting? Waiting is nothing but it needs some resources. It can be a lock resource, or it can be a memory, or it can be, so you can consider that page. It can be anything, right? It is waiting for some resources. IO, whatever it is waiting for some resources, right? So if this is waiting, so this should not be collide. Collide as in this should not be in the same queue. Let's say, as I said, right? So it should be in the first in, first out. Let's say what if it is in the same queue, ready to execute? And then what if it is wait for resource in the same queue? What if it is ready to execute another thread? What if all these three in the same queue? Now let's say the thread is coming out of CPU and it is giving signal to the next thread. Whatever thread in the queue will go ahead and execute. What if this thread is coming out of CPU and we have wait for resource thread? That cannot execute because that is waiting for resources, right? So that should be segregated. That should be divided. The queues also divided so that it will understand this queue is for ready to execute. This queue is for the waiter threads, and the next queue is for some dedicated threads. Let's say IO completion, whatever it is, some different queues we will maintain. Right? That is what it is. Runnable queue. This is some thread pull, queue request, whatever it is. Right? So this is some queues that we will maintain. Let me see if I have this. Okay, fine. So we have a different queues. So whatever we see here, runnable is nothing but all are ready to execute, right? All threads are available. It has all its resources and it is readily available to execute. So that is the reason if you see any of your queries, select start from sys.dm exec request. This is a dedicated connection, right? So let me close this connection. Connect. Yeah, any questions? Request where status equal to, you will see runnable. Or if it is there, that you will see that. Okay, whatever. You don't see here because we don't have any runnable task, but you will see the runnable queries, right? If you see the runnable queries, you can consider that the queries, whatever it was waiting for, all has the resources and ready to run on the CPU. It is waiting for, basically it is waiting for CPU to be available, right? I'll show you. We have a representation like once the thread is available, once the CPU is available, the status of this runnable will be changed to running, right? Because that is currently running. Likewise, we have something called waiter queue, right? Whatever threads which are waiting for, it will be in the waited queue. So different queues we will maintain. So I will talk about the queues in a bit. So we have different queues which manages the threads and it will be executed, so that we will have understanding which thread is for what reason, right? So this is what we already talked. UMS design goal, control which thread should run from CPU. We try to run one thread per CPU, but there are exemptions. Exemptions is basically when there is a parallel threads, right? So parallel threads cannot run on only one CPU. Parallel threads, multiple threads will spawn for one task and will execute on multiple CPUs. That is a parallelism that we will talk later. Priority is irrelevant. I told you priority is irrelevant because SQL Server, every thread will be on the same priority, that is 7. Okay. Non-complete scheduling, just some construct to make a better decision when we allow OS to schedule our threads, right? Non-complete scheduling, right? So we will not, so just some construct to make a better decision when we allow OS to schedule our threads, right? So we are just telling OS, we are just so managing our OS, managing our scheduling, right? We are not letting Windows operating system to manage on its own. We are telling, or we are giving some instructions to the Windows operating system to schedule our threads. This is what I was talking about, the context switches, right? So when there is a multiple threads on the Windows operating system, each thread after 4 milliseconds, it will go back and write the context. Context is nothing but what is the current status of the thread. It will be write into the registers and it will load that register back whenever that thread is going to execute, right? Support asynchronous IO. So we will talk about the IO when we talk about, so IO troubleshooting. We will talk what is synchronous IO and asynchronous IO, right? So we will talk about this, right? So few terminology, quantum that we already talked. The time slice, a thread is given to run by a Windows scheduler, right? Windows creates an illusion that all threads run concurrently by partitioning the time each thread is whatever it is, 4 milliseconds that we were talking. Quantum switches, saving information. Is this true? Maybe the text itself is, font itself is more, but yeah. So context switches is saving information for old thread, loading information for new thread. That's what it is, right? So whatever thread which is coming out of CPU, it has to write the thread context, right? Where the thread is coming out of CPU. I mean, out of CPU as in like it will be in the kernel mode only. It will come out of that execution mode to the queue. Thread states running, suspended, runnable. So running is currently thread is running on the CPU, suspended. So if the thread is waiting for some resources, for example, so don't worry what I'm doing here, but just I will use. How many of you already use the SQL SSMS 21 preview? This is the recent one. If not, I right? So let's say, for example, I am okay. I'll just use begin update. Something I'm just updating. Don't worry what I'm doing here. ABC, right? So I'm just updating something, right? So these many rows are updated because I haven't used the where condition. That's fine. So next I'm executing. Let's update this right? So this will never complete because it is waiting, right? So let's say if you see here, select star from, there are DMVs that we use. If you don't know the DMVs, like maybe we will talk high level, what are the main DMVs that we use. But this is one of the DMV I preferably use whenever I troubleshoot any of the queries, right? So even if you notice any queries without this DMV, you cannot even identify what is the query which is currently running and taking time. So this is a very important DMV, dynamic management view, right? Understand that we were working on, right? So where um, session ID is greater than 50. The reason I'm using this 50, because whatever 50 threads, it will be a system threads, it will be executed. So that is the reason I'm using only 50, so that whatever connection that open this database, it will be open, right? But not restricted only within 50, right? You can see n number of, so system threads can be open even more than 50, right? So like this, right? So you have background threads and all. Now, if you see here, suspended here, and you see that running here, running is, I think, current thread, current session, executing session. And suspended is basically if the thread is waiting for some resources, it is considered as suspended, right? So it is waiting for lock. It is basically a locked, right? Right? A thread is currently on the waiter list waiting for a resource. That is where you see that is suspended. So if it is suspended, where is the session suspended is 73. I'll take that session as 73. If the thread is suspended, what I told, you will not see any of the CPU time. So have you seen that CPU time? So CPU time will not be increased at all, right? If it is suspended, the query is not actually waiting for CPU, or sorry, the query is not actually running on the CPU. It will be keep, it will be on the same state, right? 2 milliseconds, because it took some time to start the query, but then it is waiting for some resources. So it will not be.
So during this time, the thread is not assigned for this task, right?
Thread is assigned. So thread is assigned to the task, but only thing, thread is not executing on the CPU. Thread is assigned. Like if the thread is not even assigned, so we will talk that in a bit. But if the thread is not even assigned, you don't even see that session is executed here. So you will see whatever queries, whatever sessions, whatever details that you see here, only if the thread is assigned to a task. Otherwise, the query is not even start executing. Is it
Okay.
clear? Thread is assigned. The thread is waiting for some resource. That is the reason it is showing as suspended. But you don't see CPU increasing. The reason, it is not actually currently running on the CPU. It is come out of CPU and waiting in the waiter queue. Runnable is your thread is currently on the runnable queue. I told you, right? So there are different queues. This is runnable queue, is ready to available or ready with all its resources and ready to run or execute on the CPU, right? It is ready to execute on the CPU. That is what we see runnable queue. See. Again, like, so same thing, runnable queue, a list of processes that are ready to run. Waiter list, a list of processes that are waiting for some resources to be available, right? So this is what we talked. Worker queue, a list of processes that are required to given a scheduler and are waiting to be served by a active worker thread, right? So worker queue is basically, uh, you can consider the thread pool. It is waiting for some task to be assigned to a worker. So that will be a worker queue. There is another list called timer list. I told you, right? Checkpoint, lazy writer, non-yielding, lock monitor. So all these will be dedicated threads. It will be in the timer list. There is a IO request, right? So let's say, for example, the thread is waiting for some IO, like a asynchronous IO I was talking, right? So this posted an IO operation. IO is nothing but like it requires some pages or it needs some data, right? Or it needs to access the storage, right? If that is the case, it will be again divided. Whatever thread is waiting should be divided, right? So that is the reason we have a dedicated queue for IO request as well. Whenever there is a IO request is posted, then that request will be tracked under this particular queue, right? So then it will be in this particular threads in this particular request, right? Again, like, so unordered list of threads that are suspended. No time limit for a thread on the waiter list, definitely, because we don't know how long the thread will be waited. No limit on the number of threads on the waiter list, obviously, because we don't know how many threads are actually waiting for whatever the resources, right? So this one, you will see select star from sys.dmos waiting task. This DMV tell how many threads are currently waiting, the waiting task, right? So currently waiting for some resources. Again, like there will be a number of background tasks. I don't worry about that. If I take that select greater than 50, right? Whatever it is. So if you see here, R thread, whatever thread which is there, this 73 thread. Um, right? So you can see here, like, so 73 here, that is the thread, what I'm worried about, right? It is waiting for some lock resource, right? So that is where you see whatever threads which are currently waiting, that is what we see. We will talk about this DMV and we have another DMV called sys.dm underscore OS wait task. This will tell what is the wait time since my SQL service is restarted, right? Suppose if you want to go back and see the history of the top wait resources since my SQL service is restarted, this is the place where you can check the history of my wait resources, I mean wait types or wait resources. It doesn't have a session ID and all. Session ID is only for the particular current executing task, right? It is a historical information if you want to gather. This is where it will uh, give. But historical as in like since when? Since the SQL service is restarted. Descending. So you can, I'll give you a few queries because I have that, where we will have to join multiple things, tasks and all to understand the top weight task, top weight resources that you see, right? So sleep and all that is like there are few things that you don't need to worry at all, right? So that is this query will tell what are the historical weights, right? Which thread are currently waiting and what they are waiting for. So the runnable queue, again, I told you, it is a first in first come, right? Whenever the thread in the first scheduler, first thread in the scheduler, that will go ahead and execute, and the next thread, next thread, next thread, so and so forth. So it will be go ahead and execute. OS scheduler that we already talked. Count, runnable task count, right? Just a representation like how this works, right? Let's say I have schedulers and I have multiple list that I told, like multiple queues that I told. And this is the running, which currently running on the CPU, the thread. This you can consider one worker, right? And this is another list, timer list, where your CPU, where your checkpoint threads and everything will be executed. This is your IO, where it is posted in IO and waiting for an IO request to be completed. And this is your waiter list, like whereas your whereas your what we call, so thread is waiting for some resources. Now let's show you that. So now if this is a currently in the runnable queue. I told you, right? So multiple threads with the same priority in the runnable queue. SQL Server will maintain the same priority, of course. And now let's go here, right? So let's say thread which is currently running on the CPU. See here, this is currently running on the CPU and it met some yield point. It should come out of CPU. It is not waiting for any resources. It met yield point, it come out of CPU. As soon as it is come out of CPU, it will always be at the end of the queue, right? It is not good and fit somewhere else. It will be always at the end of the queue. Not only this, whatever thread we see, whatever thread is waiting, whatever thread is ready to execute, everything will be in the runnable queue. It should go to the runnable queue, then only it should go and execute. You know what I mean? Suppose let's say it is waiting for some resources, some lock. As soon as it acquires a lock, it will not go ahead and execute on the CPU. It will follow the process of going back to the queue at the end of the queue and wait for its turn to execute on the CPU. That is the reason I said first in, first out. Right? If you just take this representation, first thread which is running on the CPU, it will go back to the end of the queue. Whatever the first thread in the queue, it will go back to the execute on the CPU. Next one, in the IO list, let's say IO list, whatever thread which is waiting, and it will go back to the end of the runnable queue and waiting for CPU to be available, waiting for all its preceding threads to be completed, right? Likewise, timer, right? There will be a timer queue that will be at end of the CPU, right? End of the runnable queue. Likewise, waiter, it will be end of the runnable queue and will be waiting for CPU to be available. Here you see here, there is another pool of workers here. These will be whenever a task is sorry, whenever a task is created, this task should be assigned to a worker, right? That worker will be assigned from the available worker pool, right? So this is how that is, right? So this is how the worker pool threads will be assigned, right? This is how the scheduling works. In a just a high level, if it is pending, right? I have no, okay. So if the thread is pending, if the task is pending, pending is basically it doesn't have any thread or no CPU, right? So it doesn't have any thread, available thread to take your task, right? It will be in a pending task, right? So no thread will be assigned. If it is a runnable, a thread will be assigned. Thread is assigned. Thread is not waiting for any resources. It will be waiting for available CPU. CPU available so that it will go ahead and execute on the CPU. So that is what it is, runnable. Now the thread is ready to run on the CPU. It will be in the runnable queue. Now the thread is currently running on the CPU. I have a thread and CPU. So it will be in the CPU and the status is running status. Suspended is basically waiting for some resources. It can be anything, IO, whatever it is in the suspended state. Sleeping session. I am doing nothing, right? I am not doing anything. The thread is executed and completed its execution and it is kind of idle. For example, if you see here, okay, select star from DM, sysdem DM, exec request, right? Where status equal to sleeping, right? There are many sessions. It can be a background, it can be whatever it is. So the sessions are in sleeping state where those connections or those sessions are idle, right? It is not doing anything, right? That is what the representation here, right? So sleeping is I'm not doing anything. So this is how the thread states will be changed. Okay, so high level, I'll just explain this and I'll wrap up today. Sorry, we took some time, but yeah, I'll just explain and we'll conclude for today. Worker request decision tree. Let's say there is an incoming request. We open a connection and trying to execute some request, right? So then it will check whether the worker is available or not. There are chances the workers are exhausted, right? Let's say you have a huge number of workload, the threads itself are exhausted. Exhausted is nothing but you don't have enough threads to take care of your workload. Then it will be kind of pending. It will not be assigned to any of the workers until and unless an available worker is um, taking that request. So it checks whether the available worker is available. If available, assign the request to the worker and it will be assigned sending back to the runnable queue for the runnable queue, and it will be ready to execute on the CPU as long as the CPU is as soon as the CPU is available. If the thread is not available, the worker thread is not available, then it will be in the worker limit reached. It will check whether the worker limit has reached. If the worker limit has reached, then work request in the queue, right? So it will be in the queue until and unless worker thread is available. If the worker thread is not reached, create a worker and assign the request, right? So this is how the flow will be. Suppose if the worker limit is reached, the thread will be waiting until and unless an worker is available, right? Let's say, for example, T1 task assigned to thread 1 and you don't have available workers. Then Tnth task will wait until one of the thread is available. So let's say, for example, T1 thread, T1 task is completed. Now T thread 1 is available. Then Tnth task will be taking that thread 1 and proceed with execution. This is how the flow will be. So incoming request will be assigned initially checking the thread is available or not. If thread is available, and assign a task to the request and it will be placed into the runnable queue. This is runnable queue. Runnable queue, right? Once the runnable queue right? So this is the runnable queue, and once the runnable queue threads will be go ahead and execute on the CPU. If the thread is not available, worker thread limit is reached. If the worker limit is reached, and it will be in the queue until and unless the workers are available, or until and unless we increase the number of CPU, whatever it is that we will have to take action or close the connection, whatever it is there, right? If worker limit is not reached, create a worker and assign the worker. So a thread will be created and that thread will be assigned to a task, right? So this is how that works, right? So any questions?
Can you please go to page number 24, the picture where it shows runnable.
Page number 24. Okay.
So here in case of runnable option, thread is available, but there is no worker. So from Windows OS, there is no more.
Runnable, no. Runnable, I have a thread, but no CPU. What I mean, like the thread is currently waiting for CPU to be available so that it will go ahead and execute on the CPU. The runnable is nothing but there is already a thread currently running on the CPU. That thread which is currently running on the CPU should be yielded, should be come out of CPU so that the next available thread in the runnable queue should go ahead and execute.
So yeah, that's what. No CPU in the sense that there is no worker.
No CPU as in
I'm
CPU
wrong.
as in CPU is busy currently. When CPU will be busy, there is a thread currently executing on the CPU. That is what we call it as a no CPU. No CPU as in it doesn't have a CPU cycle. So currently there is a thread currently running on the CPU. So these three threads waiting for CPU to be available. So
Okay.
if one person is running currently on the CPU, then these three can consider that the CPU is not available. because there is some other thread is currently running. So that is what we mentioned, like there is no CPU for these particular threads to be uh, executed.
Okay, okay. So can we compare yield to quantum in Windows OS? So these both are not comparable, or it is
This is
comparable?
not comparable. This is SQL level.
Yeah, yielding is equal level and
No, no,
quantum is.
I mean, so yielding again, like it will be in the SQL, it will be in the this one. So you can consider that running on the CPU is nothing but SQL doesn't have a CPU, right? SQL just a layer where we schedule the CPU, schedule threads on the CPU. You can consider this as a Windows CPU, which is currently running a thread.
Okay.
Yeah. So see, uh, thread cannot run on the SQL OS. SQL OS is just to schedule the threads. Once
Yes.
the thread is scheduled, where the thread will be executed is only on the Windows OS, Windows CPU. So this one I am talking is running on the Windows CPU. It will be come out of the CPU and it will be in the runnable queue, end of the runnable queue. So whatever thread is available in the first thread in the runnable queue, it will go ahead and execute on the Windows operating system or Windows CPU. And it will be, who is scheduling this is your SQL Server.
Yes. Okay.
Clear?
Yeah, it is clear. Thank you.
Sure. I know it is very late for people who are connected from US. So, but I'll stop here. I'll stop the recording.